Back. In the previous session, we have seen what are the properties of convolution. In that we have seen what is a commutative property, what is a distributive property, what is the associative property. And from that we have decided that if two systems are cascaded, then overall impulse response is nothing but the convolution of two impulse responses. And if two systems are in parallel connection, then overall impulse response is nothing but the sum of the two impulse responses. These things what we have seen. Let's say some more properties of the convolution. What it is saying that, suppose this is called as limits property. That means sum of lower limits of x of t and h of t. Sum of lower limits of x of t and h of t is nothing but lower limit of y of t. Lower limit of y of t. Next, sum of upper limits of x of t and h of t is upper limit of y of t. Upper limit of y of t. Let's see diagrammatically to understand it better. Suppose if I take x of t, which is something like that. Don't try to draw exactly the same way. So anything can be arbitrary signal I am taking. Let's say a is the lower limit, b is the upper limit. For x of t signal, a is the lower limit and b is the upper limit. If it is convolved with h of t, which is some other signal which is existing from c to d, then y of t, don't try to see that yes, is it going to give you the convolution of these two signals, this one. No, I don't know. I'm just giving you some arbitrary signals. So let's say we are going to get some arbitrary signal. From this property, the sum of lower limits, that is nothing but a plus c, is nothing but the lower limit of y of t. So what is the lower limit of y of t is nothing but a plus c. What is the upper limit of y of t is nothing but b plus d. Suppose if you take a numericals, then you can understand it better. Let's say it is existing between 1 and 5. Suppose it is existing between 2, let's say 3. Then what is the lower limit of y of t, which is nothing but 1 plus 2, which is 3, and 5 plus 3, which is 8. So this is the property of limits property. That means if you take the sum of lower limits, it is going to be the lower limit. If you take sum of upper limits, it is going to be the upper limit. That's what the meaning of it. Next, one more thing I want to say here. If you try to understand what is the width of x of t, which is nothing but 5 minus 1, 4, and here 3 minus 2, 1. What is the width of this 8 minus 3, 5? So if you observe carefully, width of x of t plus width of h of t is going to give you width of y of t. This is called as width property. What is it saying that width property? Width of x of t plus width of h of t is equal to width of y of t. Width of y of t. Okay, take it. Okay. Now let's see how we can apply this width property for discrete time signals. Is it same as this continuous time case? That means in the continuous time case, if you take width of x of t plus width of h of t, it is going to give you width of y of t. It is in the continuous time case. Is it exactly the same in the discrete time case? That's what we have to see. Let's see. Suppose let's take a x of n signal which is like this 0, 1, 2. This is n. Let's say convolution with a h of n. Zero, 1. Okay. Now try to understand what is y of n. That means I am not asking what are the samples, but I am asking what is the lower limit of y of n, which is nothing but 0. What is the upper limit of y of n? 2 plus 1, which is nothing but 3. So 0, 1, 2, 3. Okay. Now listen carefully. I am trying to see what is the width property in the discrete time case. Now, can you tell me what is the width of x of n signal? So many people think that it is 2. Why? You are thinking that width means it is going to be 2 minus 0, that is nothing but the width. Remember, in the discrete time case, we will never calculate width in terms of like a 2 minus 0 like that. We cannot do that. What we will do is, width of a signal in the discrete time means it is nothing but number of samples. Number of samples. So what we have to check is how many number of samples are there? 0, 1, 2. That is nothing but 3 samples are there. So here the width of x of n is nothing but 3. So remember, number of samples is equal to 3. Here number of samples is equal to 2. How many number of samples are there? 4. So 3 plus 2 has to become 5. But instead of that, we are getting y of n having samples which is nothing but 4. So from this I can say, if n1 number of samples are there, n2 number of samples are there, then how many number of samples are there in y of n is nothing but n1 plus n2 minus 1. That's what the meaning of it. That means it is having 3 samples and it is having 2 samples and it is having 3 plus 2 minus 1, which is nothing but 4 samples. 4 samples. So I am writing that the property number of samples in x of n is equal to n1. Number of samples in h of n is equal to n2. Then number of samples in y of n, which is nothing but n1 plus n2 minus 1. So that is the formula for number of samples. Here width plus width is equal to width of y of t, but here width plus width is not equal to width of y of n. It is minus 1 we have to include. Okay, keep it in mind. Question number 23. What is question number 23 saying that if x of n is equal to 1, 2, 3, 4, h of n is equal to 4, 3, 2, 1. Here is the arrow. Now Find y of n. Find y of n. Find y of n. Okay. So this kind of problem already we have seen, but in that h of n has to be written in terms of impulses. But I am giving you one procedure which is a very simple to understand, and there is no proof or something like that, but just remember it like a proof, just remember it like a procedure, so that it is going to be very easily done. So what is the procedure to find out the output when x of n, h of n, and they are having the finite width? Okay. Now listen, simply what we have to do is, whatever the sequences are given, take them. That means 1, 2, 3, 4. Next sequence 4, 3, 2, 1. So it doesn't matter what is the length, where is the arrow, it doesn't matter for us. So where the arrow is there, we don't care. Where, how much is the length of this signals, I don't care. So simply we have to write from starting to end. Okay, like that. Once we write that, simply I will do the multiplication. What do you mean by multiplication? Let's say first we have to multiply with 4. 4 into this one. So that is 4 multiplied with 1, 4. 4 multiplied with 2, 8. 4 multiplied with 3, 12, 16. Next, we have to multiply with 3. Once we start with multiply with 3, then don't start it from this column. Start it from where it is starting. That means where the 3 is there, start from that column itself. That means from 3, here is in this column. So 3 into 1, 6, 9, 12. Next, start from 2. 2, 4, 6, 8. 1, 2, 3, 4. So simply add them. Then we are going to get 4, 11, 20, 30, 20, 11, 4, which is nothing but the output. As simple as that, which is nothing but output. But here there is something we have to remember. Where is the arrow we have to keep? So while we are calculating this, I don't worry about where the arrow is, but finally once we got the answer, we have to keep somewhere arrow. So where we have to keep the arrow? For that, now let's try to understand. What is the lower limit of x of n? Lower limit of x of n? Is equal to, see, here is a 0 position, so this is nothing but minus 1. Minus 1 is the lower limit of x of n. Then what is the lower limit of h of n? Lower limit of h of n. So here is the arrow, minus 1, minus 2. So minus 2 position is the lower limit. Then we know that lower limit of y of n from the limits property, which is nothing but lower limit of x of n plus lower limit of h of n, that is minus 1, minus 2, that is minus 3. That means the lower limit position here is nothing but n is equal to minus 3. Suppose if it is n is equal to minus 3, this is n is equal to minus 3, then we know if it is n is equal to minus 3, this is nothing but n is equal to minus 2, minus 1 and 0. So here is the arrow. Here is the arrow we have to say. Okay. So this is a simple procedure, just a multiplications what we have to do. So while we are doing the multiplication, please be careful. If you want to multiply with 4, then you have to start from that column only. 3, that column. 2, that column. 1, that column only. Okay, take it. So let's say we already done one problem. Let's say x of n is equal to 4 comma 5. Already we have done this. And h of n is equal to 1 comma 2. You might remember. This problem already we have done. Can you solve this problem with the same method? Yes, we can do it. Let's see. Don't worry, just write it 4, 5, 1, 2. Just multiplication with 1, 4, 5. Multiplication with 2, 8, 10. Then if you add them, 4, 13, 10. So where the arrow has to be? Both arrows are at 0. So the lower limit is 0. So here is the arrow, y of n. Okay, take it. I want some observation here. Let's see what is that observation we can make. From x of n, can you tell me what is summation x of n? Summation x of n. That means if you sum the elements, that value is nothing but 1 plus 2 plus 3 plus 4. That is nothing but 10. Now, if we take a summation of h of n, that is 4 plus 3 plus 2 plus 1, that is also 10. But if you take a summation of y of n elements, summation of y of n elements, that is 4 plus 11 plus 20 plus 30 plus 20 plus 11 plus 4, that is going to give you 100. That is going to give you 100. This is the one thing. Next, coming to this problem. Here also, what is the summation of x of n? Which is 4 plus 5, which is 9. Then summation of h of n, which is 3. Then what is the summation of y of n? Summation of y of n, which is nothing but 27. So I want to make some observation here. 10 multiplied with 10 is going to give you 100. 9 multiplied with 3 is going to give you 27. So here, this is the statement what I want to make is, suppose if you try to find out summation of y of n, summation of y of n, which is exactly same as summation of x of n multiplied with the summation of h of n. This is a statement what we have to remember. Okay, take it. Observation. Or we can call it as a property also. Summation y of n, or we can write summation x of n multiplied with summation h of n is equal to summation y of n. Summation y of n. Now, similarly, in the continuous time case, I want to say this property. How? See, continuous time case, that means summation in the discrete time case is similar to the integration. That means integration of x of t, which is going to give you area under x of t. At the same time, integration of h of t, which is nothing but area under h of t, is equal to area under y of t. So this is the property called as area property. That means area under x of t multiplied with area under h of t is equal to area under y of t, and this property is called as area property. This property is called as area property. Take it. Area property. Question number 24 in your workbook. Question number 24. What it is saying that a discrete time signal is obtained by convolving x of n and h of n having lengths 3 and 5. A discrete time signal is obtained by convolving x of n and h of n having lengths 3 and 5. The maximum possible value of each sample in x of n and h of n are 10, 20 respectively. Find the maximum possible value of sum of all values of y of n. So I am writing that question because you may not have the question. A discrete time signal is obtained by convolving x of n and h of n having lengths three and five. The maximum possible value, the maximum possible value of each sample in x of n and h of n are 10, 20 respectively. Find maximum possible value of sum of all values of y of n. Sum of all values of y of n. That's what they are asking. Okay. Okay. First, try to understand the question carefully. So we are going to get y of n, a discrete time signal y of n better. Y of n is obtained by convolving x of n and h of n having length t and 5, the maximum possible. Okay. First, try to understand having length 3 and 5. What do you mean by that? X of n having 3 samples, h of n having 5 samples. That's what the meaning of length. Okay. And the maximum possible value of each sample in x of n and h of n are 10, 20 respectively. That means each sample in x of n having a maximum value 10 and each sample in h of n having a maximum value 20. Then find the maximum possible value of sum of all values of y of n. So in simple, I can say they want to find out sum of y of n. So for this, what is the maximum value? We have to say. So for this, what is the maximum value they are asking? So we know from the property sum of y of n is equal to sum of x of n multiplied with the sum of h of n. Okay, try to understand this. To get this sum maximum, that means this sum value we have to get it is a maximum. Then obviously individually this sum and this sum has to be maximum. I hope you understood. So I can say to get sum of y of n as maximum value, then sum of x of n has to be maximum and sum of h of n is also maximum. These two values has to be maximum. Okay. Now to become this sum maximum, individually each element has to be maximum, and to become this sum maximum, individually h of n having a samples also maximum. That means suppose each sample is a maximum value. What is the sum? That means each sample is maximum is 10 is each value. So how many samples are there? 3 samples. So I have to take 10 plus 10 plus 10. So this is the maximum possible value here multiplied with how many samples h of n is having? 5. So each sample is a maximum value, that is 20 plus 20 plus 20 plus 20. 4 times, 5 times. Then 30 multiplied with 100, which is 3000 is the maximum possible value of sum of y of n. I hope you understood. Okay, take it. Next, give a heading, procedure for graphical convolution. Procedure for graphical convolution. Okay, listen carefully. So many people fond of this procedure, that means the graphical convolution procedure, but for the gate point of view, this procedure is not feasible for us. That means we may not use this procedure because it is a little bit cumbersome process. It requires a lot of what we can say drawings. Okay, so I can say, but there are some situations where we have to use the graphical procedure. We will see that question also, so which is given in the previous GATE examination. So we have to apply this graphical procedure. It's a compulsory there. Okay, so but mostly try to avoid this graphical convolution. Okay, so even though I will make you to learn how to do the graphical convolution, but still try to avoid it as much as possible. Okay, so let's see how we can do the graphical procedure now. We know y of t is equal to x of t convolution with x of t, sorry, the pens. X of t convolution with h of t. X of t convolution with h of t. So what is the formula here? Integral minus infinity to infinity x of tau h of t minus tau dt. T minus tau dt. I can rewrite this as h of t minus tau as minus tau plus t. Minus tau plus t. This is also one way to say minus tau plus t. Okay. Now try to understand this. First, we have to convert whatever the waveform is given. That means x of t, h of t waveforms. That means graphically you know that. What we have to do is, first we have to change the variable from t to tau. That means we have to change the time axis to the dummy variable axis, which is nothing but tau. X of tau, h of tau. Now one by one, let's see the steps what we are seeing here. Step 1. Step 1. Change the time axis. Change the time axis to dummy variable axis. Axis tau. That means we are going to get x of tau and h of tau. So once we convert time axis to dummy variable axis tau, then we are going to get x of tau and h of tau. Once we got this, what is the step 2? Step 2 is, if you observe carefully, we require x of tau. We already got that. Next we require h of minus tau plus t. H of minus tau plus t means first we have to convert h of tau into h of minus tau. That means we have to fold h of tau signal. That means fold h of tau signal. Fold h of tau signal. We are not making any changes in the x of tau. So that means we are going to get still x of tau and h of minus tau. H of minus tau. Next, from h of minus tau to h of minus tau plus t we have to get. So what is the step 3? Step 3 is introduce a time shift of t in h of minus tau. Introduce a time shift of t in h of minus tau. In h of minus tau. Then what we are going to get? X of tau h of minus tau plus t. This is what we are going to get. Okay, once we got x of tau and h of minus tau plus t, what we have to do? Simply we have to multiply them and find the area to get y of t. That's what we have to do. So step 4, multiply x of tau and h of minus tau plus t and find area to get y of t. To get y of t. So this is the final step. So in simple, I can say there are only 3 steps we have to follow. What is that? Folding, shifting, multiplication, area. So folding, shifting, multiplication, area. These are the steps we have to follow in the graphical procedure. Okay. First take down these steps. Then we will see one example you can get. Let's say if they said e power minus at u of t convolution with let's say u of t. So try to understand. Let's call this as x of t. Let's call this as h of t. Okay. First what we have to do? We have to change the time axis to dummy axis tau. So what is x of tau? Which is e power minus a tau u of tau. So if I draw this graph with respect to tau, how it look like? Let's keep on decreasing, exponentially decaying function with respect to tau. This is how x of tau looks like. Next, h of tau. H of tau means whose value is equal to 1 because it is u of tau. How it look like? This is how it look like. Next thing is we have to fold the signal. That means we have to find out h of minus tau. H of minus tau, how it look like? This is how it look like. H of minus tau. Now we have to introduce a shift. That means h of minus tau plus t. That means this is actually u of minus tau. This is u of minus tau plus t. If I draw it with respect to tau, this curve, how it look like? It is all depending on the t value. If t is positive, it will look one way. If t is negative, it will look another way. Let's say if t is a negative, let's call it is u of minus tau minus 2. If I say minus 2, t value, let's take it as a minus 2. Then how it look like? This is how it look like. This is the t, 0, tau. So this is how h of minus tau plus t if t is negative. If t is less than 0, how it look like. Now, if I multiply this signal h of minus tau plus t with x of tau, will I get anything? No, nothing, because before 0 that is 0, after 0 this value is 0. So finally I can get x of tau, h of minus tau plus t is equal to 0. From this I can say y of t is also 0, because area under this curve we have to find out, that is also equal to 0 for t less than 0. For t less than 0. Next, what if I take h of minus tau plus t if t is greater than 0? H of minus tau plus t, that is u of minus tau plus t. If t is greater than, it's look like this. It's look like this. Now, if this signal h of minus tau plus t is multiplied with x of tau, how it look like? Then this is going to give you x of tau, h of minus tau plus t. This is going to look like this with respect to tau. So if you observe carefully, this signal is multiplied with this one. Before 0 it is 1, that value is 0, so it is 0. After t, its value is 0, so that value exists, but still it is going to be 0. So only we have to consider the curve e power minus a tau between 0 to t. So it looks like this, only up to 0 to t. This is what it is going to be. Understood? So what is this actually? E power minus a tau only, but 0 less than tau less than t. So this is when t greater than 0. If t greater than 0. Now we have to calculate the area under this curve. Area under this curve. So what is y of t? Y of t is equal to integral 0 to t e power minus a tau d tau, which is equal to e power minus a tau by minus a 0 to t, which is nothing but 1 by a into 1 minus e power minus a t. So that's what we are going to get. So this is y of t when t greater than 0. When t greater than 0. So in simple, y of t is equal to 0 for t less than 0. Y of t is equal to 1 by a 1 minus e power minus a t when t greater than 0. So finally I can write y of t is equal to 1 by a into 1 minus e power minus a t u of t. What u of t indicates? Which is existing only for positive values of time. Okay. So this is the graphical procedure, how we can apply it. Okay, take it. So see this. The impulse response and input of an LTI system are shown in figure. Obtain y of t at t is equal to 2. Okay. So they have given options 0, 1 by 2, 3 by 2, 1. So they have given h of t. Zero, 1, sorry, 0, 6, 1. This is h of t they have given, and they have given x of t. x of t. They want to find out y of t at t is equal to 2 seconds. Y of t at t is equal to 2 seconds. Okay. So let's see, graphical convolution is much simpler in this case. How, sir? How it is going to be much simpler in this case? Listen. We have to calculate y of t. That means I can take the formula integral minus infinity to infinity x of tau h of minus tau plus t dt d tau. At a particular instant, that means at t is equal to 2. At t is equal to 2. We want to find out what is y of t. That means y of 2. Wherever t is there, replace it with 2. That means integral minus infinity to infinity x of tau h of minus tau plus 2 d tau. So we have to calculate x of tau h of minus tau plus 2. Once we calculated them, we have to multiply them and we have to calculate the area under the curve. So if I do that, let's see. First we have to convert everything into tau. So this is going to be tau. This is going to be tau. In the graphical convolution, first we have to convert t into tau. Next we have to calculate h of minus tau. H of minus tau means it looks like this. We have to fold the signal. If I fold the signal, it is existing from minus 6 to 0. Minus 6 to 0. Now we have to find out h of minus tau plus 2. That means if I know h of minus tau, how we can calculate h of minus tau plus 2? That means what is the operation we have to perform on h of minus tau so that I can get h of minus tau plus 2? That means we have to simply delay the signal by 2 seconds. If I delay the signal by 2 seconds, this is existing like this. This is existing from minus 4 to 2. This is what it is. Now if I multiply these two signals, x of tau and h of minus tau plus 2, then only we have to consider this part. Then how it look like? Zero, 2, 1 by 2. This is the only portion we got. So if I try to find out area under this curve is nothing but y of 2. So what is the area? Y of 2 is equal to half base height. So 2 to get cancelled, finally 1 by 2. So this is where we can apply the convolution by graphical procedure in much simpler way. Okay, take it.